Welcome to qnawire.
Hi, so in this case we want to know what is the importance of lambda max in UV visible spectroscopy. So remember that whenever we have a measurement in UV-VIS spectroscopy, what we're plotting is the intensity or the absorption with respect to lambda. And in our UV-VIS spectrum, what we're going to see is that we're going to have some peak that has a maximum, and we can have potentially other peaks. But the importance of the maximum wavelength of absorbance is that this is telling us information about the energy difference in between the ground state and an excited state. So, with this lambda max, we can calculate this energy difference, and this is telling us what is the process that is happening in our molecule whenever we hit it with UV visible light. So, when we have a molecule, we can have a ground and an excited state. Then we hit it with UV visible light. Let's put it here. And what is going to happen is that one of the electrons is going to get excited to a higher energy level. So let's say that both of them stay coupled as a singlet state, and we have this scenario. So the energy difference in between these two guys can be related to the wavelength of absorption. Now, furthermore, the other part of the question to ask us why are spectra rarely shown in their raw form. So, in this case, what I did was trying to draw a spectrum that is already defined. But in actuality, what happens is that here you can have intensity or absorptivity. Both are correct depending on the device that you have. But what you're actually going to have is that you're going to have like a bunch of peaks that is noise from the instrument. And essentially, your spectrum is going to look like this. So, what we do is apply different techniques. For example, taking out the baseline with respect to the solvent that you're employing, that get rid of the noise coming from the solvent. You can also smooth the lines over here, or doing Fourier transforms of the spectrums that you're using, depending on the spectroscopic technique that you're employing. In the case of UVBs, the more common techniques that you're going to do is smoothing of the lines and taking out the baseline from the solvent or the device that you have. You can also have some different background signals coming from the instrument itself. For example, when the instrument is not hot enough, you're going to have more noise in your measurement because it affects the sensibility of your measurements. And that would be all. Thank you very much and have a good one.